So let's quickly go to the bitwise operators. This bitwise operators is very bit of trickish. Okay, so we just is a and not is and or not SO. Okay, and left shift and right shift. Sorry, I made a mistake here. This is right shift. Okay, so bear it in mind is the right shift, not left shift. So let me change that. So this is right shift. So what this bitwise operator does that whenever you want to do a bitwise operator in any value, it will first of all convert that value to binary. It will not work on it on a decimal number. It's going to work on it as a binary. So let me show you, and know that, mind this symbol now. Know that in Boolean operators, this symbol is double. This how will I call this symbol is double, but in bitwise is single. Likewise the OR. In Boolean operators, the OR symbol is double, but in bitwise operator it is one. And if you check the NOT in Boolean operators and the NOT in bitwise operator, their symbol is different. Okay, so mind this symbol. That's why I stated these symbols. So how do we do bitwise operators? Okay, first of all, let's go to this bitwise operator. Let's say we want to do a bitwise of this 7 and 10. Okay, want to do bitwise operator and bitwise operator of this 10 and 7. So how do we do it? After declaring your variables, assigning it a value if you like, we'll come down here. We now say G is what we hold. We store the value that we are getting from these bitwise operators. We are doing bitwise operator of 10 and 7. So we use this G to store it. That's why I declared the G here. You can see where I declared the G. Okay, to store the answer that we are going to get from the A and F. Okay, so we want to do a bitwise operator on A and F. So this A means 10, this F means 7. So how do the bitwise operator works? What bitwise operator will do is that it will convert those numbers to binary. Okay, and the binary number of 10 is this, and binary number of 7 is this. Then let me show you the timetable. Okay, see it here. If you look over here now, you will see that the binary number of 10 is this, and the binary number of 7 is this. So how do the bitwise operator carry out the assignment? How does it works? So what it does is that it will first of all split out these numbers in their binary form. Then it will start comparing them, just like normal AND gate, what normal AND gate do. So in this thing, it will compare this 0 and this 1 here. So 0 and 1, just like two inputs of AND gate. So, and we know that AND gate will only give you 1 when the two input is 1. So like now, if you look at one of the input here, which is this 0, and one of the input here, which is 1, you see that what we are going to get is 0. So what we are going to get in this place is, so this bitwise operation. So how are we going to do the bitwise operation? So it's going to treat it as like normal AND gate that has two input. Okay, remember it will convert this 10 to its binary number and convert 7 to its binary number. So then it will do an AND operation on it. So this is 0, right? One of the input. This is 1 of the input. So 0 and 1, and you know that AND gate, that the two input must be 1 before you get an output 1. So that means the true input must be true before you get a true output. If one of the input is true and the other input is false, you will get a false output. So here, one of the input is 0, one of the other input is 1. That means we are going to get a 0 output from it. Then this one is 1, the other input is 1, which is we are getting a true the two input is true. That means the output is going to be true. That's why we have 1 here. So if you do the same calculation, the same AND operation in these two values, you see where we get these zeros. Okay, so if we try to print this G now that is holding this value, what we are going to get is 2, because this is 2 in binary form. Let me show you the timetable. So let me show you the table. This is the table here. So where is 0010 is 2. See it here. This is the table. 0010 is 0. So whenever you do an AND operation, whenever you carry out an AND operation in two value, is going to convert it to binary first, then and do the AND operation on it. Okay, so likewise if we use the OR, so let's see the symbol of the OR. So the symbol of OR is this one. So if we do the symbol of OR here, so let's do the symbol of 4, and you know that symbol of 4 is that one of the input must be true before you get a true output. Okay, so let's say this one is 0, this one is 1. That means we are going to have one value here. So this one is 1, so we are going to have 1 here too. So look at this. So we are going to have 1 1 in all of them, 1 1 in all of them, because we are carrying out the OR operator. This is the OR operator. Either one of the input is true. So if one of the input is true, we get a true value. But if the two input is false, we are going to get a false value. Okay, so this is this is OR operator. So if we look at the value, the binary value of this answer we get, let's check the binary value of it. 111. What is 1111? Let's check 1111. Okay, we don't have the 111 here, so maybe it has exceeded from this timetable. Okay, but I know it's one of the decimal number, but it has exceeded from this 1 to 0. But I know you understand the operation of OR gates. Okay, I know you understand the operation of OR gate. Likewise, if you want to also do the operation of this NOT gate, it's going to invert it too. Okay, if you want to do we are not going to do, it's not going to take two inputs. So what if you want to do a NOT gate operation using this bitwise, what you are going to get is this, using the bitwise symbol. Okay, so let me say bitwise of A. So let me change it to capital letter A. So the bitwise of how is it going to turn it? I'm going to delete all this thing. If you are going to do the NOT gate operator on this number, which is 10. So 0 is 1, 1. This one will be 0. Okay, because it's going to invert it. This 0 is going to be 1, and this one is going to be 0. So let's look for the binary code of it in this timetable. Okay, we have 0101. So let's check 0101. We have 0101, which is 6. So we are getting 5. So the value that is going to print on the serial monitor is 5, because we just carried a NOT bitwise operator on this number. So it's going to invert those numbers after converting it to binary. Okay, I hope you understand this bitwise operator very well. This bitwise operator is very important that you understand it, how it operates. So this is how it operates. So let's go to the compound operator. There's nothing much in this compound operator. The compound operator is normally increment and decrement. So whenever you see plus, that means it's adding 1. For example, if I say if I say A plus plus, if I say A plus plus, what is it going to do? It's going to add 1 to this A. That means it's going to add 1 to 10, and 10 will now become 11. Remember, this is not a bitwise operator. This is just a normal increment. It's not a bitwise operator. We are in compound operator. Okay, so if you say A plus plus, sorry, I mistakenly I get it wrong here. If I say A plus plus, that means I'm adding 1 to the value of A, which is, if I add 1 to this 10, it's going to become 11. Okay, likewise if I say A minus, that means I'm minusing 1 from this 10. That means what I'm going to get is 9, because I just minus 1 from it. So anything that you are using plus, that means you are incrementing it by 1. Any value that you just put plus, that means you are incrementing it by 1. Then if you say minus minus, that means you are decrementing it by 1. That is what this symbol means. Then let me come to this symbol, this plus equals to. This is just the same thing like adding a value. For example, let me give you an example. If I say now, for example, if I say a plus equals to c, okay, what am I doing here? That means I'm adding c to a. Okay, whatever value that is here, you add it to the value that is in the left. That is what this compound of this plus equals to means. And you know this equals to is used to assign. So this equals to is used for assigning value that is in the right to the left. Okay, and this plus sign is just adding. So if you don't want to say a plus c, you can say a plus equals to c. That means it's going to add this 30 to 10. That means if you use this symbol, this type of operator, it's going to add the 30 to 10, making it 40. So if you print out this thing, it's going to give you the value of 40. Okay, likewise, if you use this symbol minus equals to, is going to minus the value in the right from the value in the left. Okay, so that is the simple way of doing a plus b or a minus b. This is another way of doing it. That's why they call it compound operators. I hope you understand this lesson about operators. Okay, so these operators is very important in programming, like I said. So I hope you understand it. Thank you for watching. See you in our next video. Bye.